Hello, second part of the final review. So, show whether these are inverses of each other by checking that f of g of x is equal to g of f of x is equal to x. So they're kind of saying, well, the answer should be x, and if it's not x, then we got a problem. So first we're going to do f of g of x. So I'm going to replace every x with g of x. So this becomes 1 over x minus 1 plus 1 all over 1 over x minus 1. And we know that from our strategies in class that we're going to multiply everything by the common denominator. And the only thing that you see that has that's the denominator is x minus 1. So I'm going to multiply every single term by x minus 1. And you'll see the reason that we do this is this will help. X minus 1 divided by x minus 1 is 1. X minus 1 times 1 over x minus 1 is 1. And so you'll see these x minus 1s are going to cancel out. And so now all we have now in this denominator is 1. And the numerator, it's 1 plus x minus 1. So 1 plus x minus 1 and over 1 is just x over 1, which is x. So that's the first part. Now we've got to check the second part. Does g of f of x equal to x? So again, does g of f of x equal x? Well, let's find out. So 1 over, parentheses, x plus 1 all over x minus 1. And a little bit of simplifying here. We're going to, again, multiply everything by what the common denominator, and the only thing, again, that's in the denominator is this x term. So it's going to be 1 times x, negative 1 times x, and x plus 1 over x times x. So this gives us x over x plus 1 minus x. And now we see we have an x and we have a minus x, so this gives us x over 1, which is also just x. So yes, these two are inverses of each other. Okay, so now let's check this one. And I know that usually the questions that we've asked in class, they've always turned out to be x, but you still got to check because what if it's not? So that's what we're going to find out in this case right here. So does f of g of x, does that equal x? Well, let's find out. Take this, and we're going to substitute it in here. So this is going to be 2 times the cube root of x minus 1 all over 2 plus 1 cubed. And again, I think everyone will do this right away, and that's great. It's a great plan. But the cube root of x minus 1 plus 1 cubed is not what you think. You can't just distribute that and think that you're going to be fine. It doesn't work that way. What this is cube root of x minus 1 plus 1 times the cube root of x minus 1 plus 1 times the cube root of x minus 1 plus 1, which is not going to give you x. So right away we see that this is not going to equal x, so we know right away they are not inverses. Okay? All right, so if f and g are inverses and f contains the points 1, negative 5, 3, 2, and 5, 9, what points must be on the graph of g? So g is equal to f inverse. So we know from our studying of inverses that all we have to do if we want to find what points are in the inverse is just change these around. So now the points that are in the inverse are going to be negative 5, 1, 2, 3, and 9, 5. Okay, there's another question on the final. Is f of x equals 2x plus 1 over x plus 5? Find f inverse. And we prepared you guys pretty well for this the first time we saw this. I remember on the test, a lot of you guys did better than we had done in years past. So I know you guys have done this really well. Remember, our first step is to rewrite this as y equals 2x plus 1 over x plus 5, and then swap out the x's and the y's. I don't know what I just did there. Swap out the x's and the y's. So x is equal to 2y plus 1 over y plus 5. And then we do some careful manipulation here. We're trying to get y by itself. So I'm going to multiply both sides by y plus 5, y plus 5. And now we're going to get xy plus 5x is equal to 2y plus 1. These will cancel out here. And again, we got to get y by itself. So I'm going to subtract 5x from both sides. So I'm going to get the non-y terms on one side and the y terms on the other side. So now we have xy minus 2y is equal to negative 5x plus 1. And hopefully we notice these both have a term of y in them. So I'm gonna pull that out, and I'm gonna get y times x minus 2. So I factored out those y terms that were common to both. And now the final touch here is I'm gonna divide by x minus 2. And now we get y is equal to negative 5x plus 1 all over x minus 2. And, it's multiple choice, so if you don't see y, then what you will see then is definitely f inverse. So f inverse of x plus 1 over x minus 2. Okay, so now, quadratic functions. Sketch the graph of f of x equals negative x minus 2 over where are the coordinates here. So first we're going to find the vertex. So we're going to use x equals negative b over 2a. And then x is equal to, identify the coordinates here. So it's the opposite of 4 over 2 times negative 1, which is negative 4 over negative 2, which is positive 2. And then just using the calculator, you could find that the y value, or you can substitute it in, the y value is 5. So that's going to be our vertex. 1, 2, 1, 2, 3, 4, 5. We know the domain is going to be all reals. It's a quadratic function. Now the range, okay, well, if we don't know it, that's okay. Let's go ahead and graph it. So if we make a table of values here, you could do that, or this follows a pattern. 1, 2, 3, 1, 1, 2, 3. Okay, so it looks something like this. If we know the range, we know that the highest point is going to be 2, 5, and it goes, these arrows pointing down to negative infinity. So looking from down to up, my range is going to be from negative infinity to positive 5. Is there a max value? Yeah, there's a max. There's no min. So there's a max at 2, 5. That's our vertex. And find the equation of the parabola. It's a different question. Find the equation of the parabola. This is on, you gotta make sure you don't do this. This is on there, okay? So again, let's get an idea of what this graph is looking like. All right, so if I sketch this, we have negative 3, 1 is one of the coordinates, and it goes to the point 0, 4. Okay, so we'll just sketch it out. So I know the answer already. So, we know it has to go up like this based on if this is the vertex. So now we're going to substitute into the formula. F of x is equal to a times x minus h squared plus k. And if we identify the major points here, this is your h, this is your k, this is your x, this is your y. So now 4 is equal to a times 0 minus negative 3 squared plus 1. 4 is equal to a times, this is just positive 3 squared, that's 9, plus 1. Subtract 1 from both sides. 3 is equal to 9a. Divide both sides by 9. A is equal to 1/3. And now we have the a value. You got to make sure you substitute it back in, because your answer is going to be in a quadratic form. So we're going to get y is equal to 1/3 times x plus 3 squared plus 4. All right. This is on there. Again, everything is on there. I'm going to stop saying that because everything is on there. So there's a question like this. We have to find Jackie has 360 feet to enclose a rectangular region. What is the maximum area? So going all the way around, we know it's 360 feet. So the perimeter would be 360 feet. We know the perimeter formula is 2 times the length plus 2 times the width. And we know, using x and y, it makes it make it a little bit easier maybe for the coordinates. We're going to say that the perimeter is equal to 2x plus 2w. And now the perimeter is 360. So 2x plus 2w. Doesn't matter which one you picked as your x. And now we solve for w. We get 360 minus 2x is equal to 2w. Divide everything by 2. We get w is equal to 180 minus x. So if we use the formula for area, area is equal to length times width. If our length is x, then our width is 180 minus x. So area is equal to x times 180 minus x. And you can either use a calculator or use negative b over 2a. Either way, if you use your calculator, it's going to be y equals negative x squared plus 180x. If you use negative b over 2a, then we're going to say, well, that's x is equal to the opposite of 180 all over 2 times negative 1, which is 90. And again, I kind of prefer to use negative b over 2a in the calculator, because now all I do is I substitute this 90 in, and that's going to give me the area. So area is equal to 90 times 180 minus 90, which is going to be 8,100 feet squared. That's the maximum area. All right, consider the graph. Find the equation in factor form. We're going to have this graph. All right, so first notice, since it's going down from left to right, so we know that it's going to look like this. So the going down tells me that the a value, it has to be a negative number. Also, since looks like this, we also know that it's going to have an odd lead exponent, right? Or degree. Okay, so now let's identify some of the key parts here. Okay, so this is a crossing zero. This is a touching zero. This is another touching zero. And what the touching zero tells us, it's going to be an even power or even exponent. Even exponent. Odd exponent. But remember, our fancy word for that was multiplicity. Okay, so we have a odd multiplicity, even multiplicity, even multiplicity. The a value has to be negative because it's going down from left to right. So a possible, not the answer, an a possible answer is negative a times x plus 3 to the first power. It could be the third power, fifth power, seventh power, but it has to be odd. Times x plus 1 squared times x minus 4 squared. So again, these have to be odd. It doesn't have to be 2. Okay, it just has to be, and these have to be even, and this one has to be odd. So this would be like 1. All right, so that is a possible answer. All right, so now let's take a look at this kind of more in depth here. So these are, now we're given the equations. What is the degree of the polynomial of this function? Well, this is the first power. So when it's in factored form, we add the exponents here. So this is 5. This is to the, this is again in factored form. So we add the exponents here. This is 5. What is the maximum number of turning points f of x could have? Well, if the degree is 5, if the turning points are both 1 less. For every large power of absolute value of x, what does the function f of x? Remember, this is called our power function. And it's basically if you were to multiply all of this out, right? X plus 1 to the first power, x plus 2 to the fourth power, and you'd have 4 of these x plus 2s and 1 of these x plus 1s, your lead coefficient, your lead term would be x to the fifth power. And likewise over here, if you multiply all this out, you have this 5 in front, your lead term, your lead coefficient, your lead term would be 5x to the fifth. And lastly, find the x-intercepts, their multiplicity, and the graph touches or graph crosses or touches the x-intercept. So we have 2 here. So this would be x equals -1, and it has odd multiplicity. And this would be x equals -2, and it has even multiplicity. And since it's odd, it crosses, and since it's even, it touches. Over here, this would be x equals -4, and that's even multiplicity. This would be x equals -11, and that's odd. This touches, this crosses. Okay, and the last one for this page, or last one for this video, find a polynomial standard form, okay, with the following 0 in degrees. 0 is 1 and 2 with a multiplicity of 2, and degree is 3. So degree is 3. It's great they said that because this has a multiplicity of 2. We have our factored form. So our factored form is x minus 1, x minus 2, x minus 2. And since the degree is 3, we know that we have them all covered because if you add this together, 1 plus 1 plus 1 is 3. So now it's a matter of multiplying it out. So f of x is equal to x minus 1 times x squared minus 4x plus 4. And multiplying this out, you can use your arrow method. You could use the method I like, which is this, and times x minus 1, and we get what's going on here? Okay, I don't know why this is not okay. There we go. All right, so -4, 4x, -x squared, 4x, -4x squared, and x cubed. And we just add them all together, and we get x cubed minus 5x squared plus 8x minus 4. So this is a possible answer.